Hi everybody, I'm back here with an additional demo of the Hall effect limit sensors I made for my Shipoko 2. The reason I'm doing a second demo is that there were some questions about accuracy and repeatability. So I thought I would do a little demo. I don't have any precision tools that can measure the minor differences that will be there, but I figured I would do this quick little demo anyway. The other thing I'll tell you is that I use the homing sequences and the limit sensors for milling circuit boards. So as far as accuracy concerns, there's no problem. The limit sensors themselves are going to be far more accurate than the belts on the Shipoko 2 itself. So really the challenge will be the belts and drive system of the Shipoko. And not to knock the Shipoko, it's a great machine. I love it. I use it as much as possible. But I figured I would do this little demo. So what I've done is I've taken a milling bit that I use for my PCB boards and I put it upside down. I got another drill bit with a very fine point on it, and I brought it to 100, 100 on my Shipoko, and I just lined everything up. So that was a manual lineup. But now what I'm going to do is I'll go through the homing sequence and I'll have it travel back to 100, 100, x100, actually x minus 100, and y100, and bring the z down to it, and they should line back up. Just a little exercise to show you the accuracy, and we'll see how it goes. So here we go. So as you can see right here, we're going to home the z point first, and we're going to come over here and we're going to home x. And then as that's happening, we're going to then come down here and home the y-axis. And now they're going to travel back to that original point. Let's see how well we keep this in focus. And there you go. It's homed. See that? It came back. Hopefully you can see that. I know it's hard to see. But as you can see, there it is. It's all homed in. Now we're going to do one more exercise. We're going to repeat this one time. But what I'm going to do, just to show you that the accuracy is there, is I'm running this on a tiny G. So I'm going to disable the motors. And now I'm going to manually move the gantry. I'm going to basically mess up my calibration. So if there's any doubt about the calibration. So I just moved the y-axis, pushing it back and forth here. And I'm going to move the x-axis gantry. Let's do it over this way for fun, see more travel on it. And I'll even mess up the z-axis a little bit, okay? So what I'm going to do is rerun the whole exercise again, and we're just going to let it run. I'm not going to do I'm not going to do all the close-ups. We'll just let it run, and you can watch what happens. So just did the z-axis. Now we're doing the x. Now it's moving forward to the y. And as soon as that finishes, it's going to go back to bang. There it is. So as you can see, it's all homed again. Let's see if we can get that lined up for you. And as you can see, there it is. It's all lined up back to where it was. Just as an example, I have a feeler gauge. It's 0.8 millimeters around here somewhere. Not sure what I did with it. Here you go. And as you can see, it's not touching, but I cannot get this through here. So that's the accuracy we're talking about. So this really does work. They're very accurate, and as I said, I've etched a lot of circuits with it. I've milled a lot of circuits with it. As a matter of fact, here is a sample of the of my limit sensor that hopefully see how well we can get in there without being too blurry. But as you can see, I can mill very small circuits, and I'm actually going to try milling some SMDs in the future too. So hope that works for you. If you have any questions, let me know. Bye.